Hi, today I'll be showing you how to break down a simple tune into its respective beeps, beep frequencies, beep durations, and gaps in between. This can be configured for your own personal use. I'm using this to play tunes on a piezo buzzer using Arduino. In the Arduino code, I have a simple beep method where the frequency in hertz is placed here and the duration of the beep in milliseconds is here, and the delays in between is in milliseconds here. You can manually create your own beeps, but if you want to replicate a beep that you've watched, you can do that by hand and listening or zooming in on the frequencies. Say using Audacity, you zoom in right at the tone and you count how many oscillations there are per every few milliseconds to determine the frequency, or you can write a Python script. Here, I've written a Python script that uses a .wav file because .wavs are lossless. If all you have are MP3s, there are many free MP3 to .wav converters online that you can use. Inside the script, there are two main sections that you need to worry about when using it for yourself. Here, there are a bunch of parameters that you can tune to help you detect the frequencies, and down at the bottom, there is print event. What I have done, I have made it so that it will print out the frequency that detects in hertz, the duration, and the gap afterwards in the same form as the Arduino code that I showed you earlier. So if it detects a beep, it'll say beep, 728 hertz, 81 milliseconds, next line, 40 millisecond delay. So it does this for all the beeps. Just the main things to keep in mind is the frequency is this here, the duration is here, and the gap in delay is here. Both the duration and the gap are in milliseconds. You will want to place your print method within the condition here where it checks if the type is a note in the event. Make sure to convert the variables to integers, otherwise you'll have some really long strings. Originally the sample rate was 22,050, but I raised it for more accuracy. I recommend that you start at 22,050 and then raise it in powers of 2 as you configure it. The tune that I am trying to replicate is one of the beep sequences produced by the Nostromo computer at the beginning of the film Alien. It is the following. And here is my replication of this tune using a piezo buzzer and an Arduino Nano. Please ignore the relay array. I am using that to replicate the clicking sounds. In order for you to use this yourself, you need to make sure you have a WAV file in your Python folder, where you type your code like this, and then you copy and paste it into the terminal. Then you leave it to run. It'll take a few moments, and then it will print out your code, or just whatever you configure it to print out. And so here, it prints out as my Arduino code, and now I can copy this into the Arduino IDE. Now, if you look very closely, you can see that there are some sections with really short delays, like 4 milliseconds, 2 milliseconds, 1 millisecond, and the frequencies between the beeps are very close. So what you can do is delete them and then add up their durations together. It's actually just one note, but it's an error within the program, because in total, the tune that I'm using has 7 notes. So we just combine all of these. As you can see, it does match the first iteration. And there we go, now we have the whole code. And I will upload this to the Arduino and show you what the result is. So there we go, that would be it for today. If you have any questions, please feel free to put them down in the comment section below. And if you want access to the code, it is in the GitHub link in the description. Thank you for watching and enjoy the rest of your day.